It's the moment of truth, the moment you've all been waiting for. The electric Evora is bolted to the dyno. Let's see what kind of Tesla jam she makes. It finally looks like a car, Sasha. There's all kinds of things here. There's drive shafts and brakes and suspension, and batteries that we imagined being there are there now. This all happened in the last, well, it's only been a few weeks. You've been a busy boy by the look of it.
Yeah, last you saw it, we had just finished getting the subframe ready to go out for powder coating, right?
Yeah, exactly.
Yep, so once we got it back, I mean, we had already had all this test fitted, so it was just a matter of reassembling it, really.
Right.
And Rapid Gear made us these awesome axles. They're nitrided, and they've got this nice finish on them.
Yeah.
And yeah, they did a really good job. So they've held up so far on the dyno, but that's not really saying much until we get on the road and actually start.
Yeah. Still, they're going to see a lot of torque, so
sure.
They have to be strong. You obviously factored that in when. Did you give them some design specifications for these, or did you just?
They did their own engineering,
and
I gave them the Tesla drive shaft and the Lotus drive shafts, and they're pretty confident that we're at the Tesla strength here.
Cool. Okay.
So it should be good.
Well, it's really neat seeing the batteries in their home now. It gives, I mean, I'm a visual learner,
right.
So it gives me a way of seeing how it all works, and it's exciting to see. Obviously, you've had it on the dyno. Are you done with the tuning side? Are you dialed that way, or do you feel like
there's
not
not really
more?
Tuning of electric motors? There's just fixing all of the limp mode and all the problems.
That's true. Yeah, you don't really have to change air-fuel ratios anymore, do
no.
you? There's no ignition timing involved.
There's no ignition timing.
So what do you do?
Well, you know, this is the first time that we've been using this controller. This controller has been used to control a Tesla motor on the dyno. Mm-hmm. So we've been working with the guys in Switzerland. Yeah. And
what's the name of that company? Do you remember?
Advantix.
Advantix. Okay.
Yeah.
So for all you electrical builders out there, maybe
That's
you
right.
can look them up.
I think they're the only ones that can make the Tesla motor work currently.
Okay.
And we're kind of their first public, anyways, testing platform. It seems like, and it's been really, really good. And then we've obviously got the Motec ECU in there, which is like the main vehicle controller that we talked about last time.
Yeah.
And so we're doing all the throttle control through that, which is really cool. So we can do all those things we talked about in the last episode.
Right.
Where we can basically limit power, or we can do different throttle mapping, or we can do the regen with the paddle.
Right.
So all those things are being done through the Motec, as well as all the other cooling controls, battery controls, and monitoring of all the voltages. So there's 192 different battery cells.
Wow.
And so each of those cells is being monitored and controlled by the Motec. So there's like just tons of voltage.
Yeah.
Lots of stuff in there, lots of temperatures, and
it's all completely sorted as far as wiring and cooling of the batteries and all that. Is that all done?
So all of the electrical control stuff's done. The water cooling is not done, and that's what you see here is all this temporary motor cooling.
And that's for the battery pack?
No, that's for the drive unit
the motor
and the inverter. And then the batteries, when we're only running for 8 seconds and then giving them a rest for 20 minutes, they don't need cooling yet. So we're okay there.
But there will be a cooling system for the batteries in its final version?
Yep. So we've got to put a catch can or an overflow there, and then all the batteries will dump into there, and there'll be an electric water pump. And the drive unit is mostly likely going to use the OEM heater core piping, and then that'll give us some heat, very little bit of heat, but some heat.
Yeah.
And then if the drive unit gets too hot, then there'll be a three-way valve that'll open up and dump it into the actual radiator.
Okay. I would never have thought of putting a quaife differential in a Tesla motor unit, but you've done that.
Yeah, the guys at EVTV actually went to quaife and had 25 custom made. Okay. So we bought one from them, and it's the same ATB helical diff that's in all the regular cars. I mean, these things have open diffs from the factory, and they're designed to use the brakes as the diff, which
it's super cheesy, and I hate with a passion.
Yeah, I mean, in theory, it can work really well, but I don't have control of it anyway.
And then you don't have any diff happening anymore. Sure. I've test driven enough Fords with that system to tell you it doesn't work well at the track.
Terrible. So now there's a diff in there. I mean, it's not going to be like a Gymkhana diff or drifting diff, but it'll be awesome for
what you're doing. It's perfect.
Yeah, exactly.
And they're quiet. There's zero maintenance. I mean, it's perfect for this kind of project.
Yeah, it's an ideal diff for like road course, time attack.
And as far as the way the battery packs are arranged, was this strategically done for weight distribution, center of gravity, anything like that, or was it just a matter of they fit in this hole? What was your thought process there?
I probably spent days just staring at it.
Really?
and trying to figure out the best way to do it. We had Chris Rugra come from CarFab and help us do the fab for the brackets for the batteries. And the idea was just to get as many batteries as far forward and as low as possible.
Okay.
So we've got the two biggest batteries on the bottom and a medium. There's 3 sizes in a volt battery. There's a long, there's a medium, and a short.
Okay.
So we've got 2 longs on the bottom and a medium, and they're as far forward as possible.
Okay.
And then the top, there's just a medium and 2 smalls. We had no choice but to put them on top. So the medium's
in front of these 2 smalls, is that right?
That's right.
Okay. So what's the overall effect of all of this to the car's overall weight and front to rear weight balance?
Yeah, so when we first started this project, we were thinking it would be about 200 pounds heavier than stock.
Yeah.
And we just weighed the car more or less the way it sits now. And we had also weighed the Evora with still a gas engine and all the gas stuff in it, but all the bodywork off, just like the way it sits now, but with, you can imagine, a gas engine, fuel tank, exhaust system, everything you need to run a gas engine.
Yeah.
And we're like pretty much exactly 200 pounds above that right now. So we're very close to that.
Yeah.
So we'll be about 3,200 pounds, hopefully.
Okay.
And because we're doing a fiberglass rear hatch from Hethel Sport, and we're also doing, the OEM battery was back here, it was like 50 pounds, so that's gone.
Yeah.
And we cut a bunch of this frame out. So we're actually going to be about 1 or 2% more front heavy than stock, which is going to be good because the car had a little bit too much trailing oversteer.
Okay.
Like a typical mid-engine car.
Yeah. So if you look in here, I see a Motec in there, Sasha. Is that where it's going to live?
Yep, that's actually where the OEM ECU was. So we're going to mount it right there. And you can see in here we've got this motorsport harness going. I mean, I've got a lot of hours into designing this thing. And, a lot of it is underneath actually this tray. So we'll pull that off and show you guys later as well.
Okay.
But so this ties everything together. I mean, there's a ton going on in this thing.
So what exactly is the Motec doing? I know we talked about it last episode, but just I'm old and senile, Pete. Let him explain it again.
Right. So the Motec is talking to this Advantix UMC controller.
Okay.
The Motec is also controlling all of the battery control and BMS function, which is basically making sure that every single cell of the battery has the same charge.
Okay.
You don't have some cells that are overcharged and some that are discharged.
Okay.
The Motec is also communicating with the dash and communicating with the OEM ABS.
Okay.
And making sure all the stability control and ABS is happy and working. It controls all the charging functionality, so we'll be able to go to a high power charger on the side of a road, like a level 3 charger, and be able to charge with like 60 kilowatts of power. So charge this thing up in 30 minutes type of thing.
Wow, okay.
It also talks to and controls the front charger, which is the low power, just overnight type of charger thing.
Right. From what I'm gathering then, this Advantix piece basically controls the Tesla motor, and the Motec's doing pretty much everything else.
Right, exactly.
That's kind of the case.
Yeah, this Advantix UMC controller makes the Tesla drive unit think it's still in a Tesla, effectively.
Okay.
And then we have just this little fancy throttle mapping thing going so that we can do traction control, and we can do different, we can adjust the speed at which the power ramps in. So you can imagine that as a driver, you could just kick the throttle.
Right.
But even if you kick the throttle, we want to program in like, no, you can't just do that. You
go from 0 to 100.
It has to be over a certain period of time.
Right.
So that you don't just roast the tires. You need to give the suspension some time to, for the weight to get on the tire, for the tire to, to flex and start contacting the road before you apply the full power.
Okay.
So we can do all those kinds of things. We can do it based on lateral G, speed, all sorts of stuff to make it.
And that's all built into the Motec system?
Well, it's in the programming that I did in the firmware, yeah. So fancy all those things we can do. Learning
Speaking
slowly.
Of fancy things, you
we got
teased
this
us with the
Regen
idea
sensor.
of your Regen paddle last episode, and now it's here in rapid prototype form.
I just prototyped this morning before
cool.
breakfast.
Things he does before breakfast.
It's got this really.
I brush my kids' teeth. He designs Regen paddles.
I know.
And it's using a really cool sensor. What is that sensor called?
Yeah, it's a pressure sensitive. I don't even know what they call it. A pressure sensitive resistor.
Okay.
And this one's FlexiForce. I can't remember the company that makes it now, but it's cool. It was like $20.
Yeah.
And it's literally the resistance across 2 wires changes based on the force.
So the harder you pull on the paddle, the more.
Well, I just built this little mechanism that basically it's got 2 bolts here, and as you pull on the paddle, it flexes onto that pressure point.
Yeah.
And then when you get to a certain point, it'll hit a stop, so you can't just flex it and bend the paddle.
Right.
So even the 3D printed one kind of works a bit. And so that's cool that we got it together for you guys to see today.
And since the Regen causes a braking effect. The harder you squeeze that pedal, the more braking you're going to get from the motor.
That's why we didn't want to use a switch, because then it would be really
on-off-ish too.
It would be like kicking the brake pedal. So this thing now you actually can squeeze it, and I think it's going to be pretty cool.
Yeah.
I don't know for sure.
Yeah.
It might be stupid.
It's a neat experiment. I love it.
And then we had a lot of people commenting in the last video about, oh, why don't you do it with the brake pedal? Why don't you do the throttle? We can do all of them.
Sure.
It doesn't have to just be one. So it'll be when you press the brake, you get regen.
Yes.
It'll also be that if you don't press the brake and you squeeze this,
you get regen there.
You get regen, and you don't have to put any heat into the mechanical brakes, which is wasting energy.
Right.
Right. And personally, I like it so the throttle pedal, when you're off the throttle, it feels like a gas engine.
Mm-hmm.
You get a little bit of compression braking.
Yeah.
But I don't want it to be like 60 kilowatts of braking, and that's too much on the racetrack and that. But.
So anything new going on with the dash display itself? I mean, obviously that's all talking with the Motec now.
That's the coolest thing, man. We finally got all the electrical in, and I was able to just nerd out and just program the dash on the display now that shows you all sorts of different things like the power and the regen and
we'll see
state
some
of
of that
charge.
when
Yeah,
you're
you'll see it all for sure. The voltage, all that stuff. So it's been really cool to see it all kind of start to come together. 2 clicks.
Nice.
Time for jam.
It's like Tupac's electrified brother from another mother. So you've spun the dyno before. You have a very good idea of how much power it's going to make. You're just doing this for our benefit at this point.
Well, there's a lot of testing that needs to be done too. Like we're kind of
in the midst of that.
We've done very few. We've only done like 2 pulls. We've never actually done a full power pull. We've only done like a pull where I floored it for a moment and then let off.
Okay.
So here we're going to do like a full power pull.
All right.
From the speeds we talked about and see. We'll hopefully have like a flat power line of like a lot of power.
So we're going to see some jam.
Hopefully.
I'm excited.
But we're just going to warm it up first.
Okay.
Put it in drive here.
Yep.
Any guesses?
No noise, no fumes. I don't know, man. I could see the whole rear end squatting. It was making power.
458 wheel horsepower.
458 wheel horsepower. Holy cow, that's serious. Wow. And talk about area under the curve too. Look at that.
Yeah, and I mean, I didn't floor it. So like, remember, I didn't floor it until here.
Yeah.
So the actual torque would have kept climbing up like this.
My God.
And eventually maxed out the dyno.
That is life altering.
And the power might have been higher had I floored it earlier. It's really hard to say.
It's almost 460. That's incredible.
Yeah.
So what was did you dyno this and like the combustion engine in this car before you started?
Yeah,
this?
Do you want to see the overlay?
Yeah, let's see an overlay.
It's kind of nutty.
I want to see what we've done here. That's crazy.
Yeah, so it's nutty, right? We basically have 200 wheel horsepower more than the base car.
Yeah, you've basically doubled horsepower.
And there's really no downtime with shifting gears or anything. It's just that's some down power that's being applied all the time.
All the time.
Yeah.
That's incredible. It's interesting when you look at peak torque to peak torque, they're roughly the same.
Right.
So that doubling in horsepower has come from the speeds you're able to spin this motor at versus the speed you can spin a piston engine at.
If you have the same amount of torque at double the speed,
you've
double the RPM,
horsepower.
you have double the horsepower. Exactly. So like we said, at 4,500 RPM, the Evora has 212 horsepower. Right? But it has 243 pound-feet of torque.
Yeah.
But in our case of the Tesla drive unit, we have 243 pound-feet of torque at 9,500 RPM, which works out to 442 horsepower.
All because we're
at 9,500 RPM. So you're able to maintain that torque at a high RPM. That is a lot of power.
See, I never realized that the speed of the electric motor was such a big advantage over a piston engine until now. That's an interesting illumination I've just experienced.
Well, it's just like if you take a Honda engine or any small displacement engine that revs much higher, you're going to see the torque is much lower for the given power.
Yeah.
You know, so that's just
the nature of RPM.
The nature of what power is, torque times RPM.
Yeah.
So you need to and a lot of people don't quite grasp that.
Mm-hmm.
And because an electric motor is able to output pretty much the same horsepower at any given speed, it doesn't need gears. It doesn't need a transmission.
Right.
I mean, it could benefit from one, sure, to, you know, maybe a 2-speed gearbox or something would be ideal, but it's so close that you're okay with just a single straight drive.
Incredible.
And imagine with a gasoline engine, if you tried to floor it at 800 RPM, it would just not even move.
Yeah.
Right? So at 800 RPM in this thing, if you floor it, you still have not 400 horsepower. It does take some RPM until it peaks.
Sure.
The motor, but you still have heaps of power. And to have heaps of power right from 0 RPM, that's what people talk about when they're talking about a huge amount of torque.
Yeah, that's what feels fast, and I think that's...
Because at that instant, at the motor, you do have a ton of torque.
Yeah. Wow. No fumes, no noise, Pete. It's weirding me out.
470.
470.
But that's not really fair because that's the dyno kind of like grabbing.
Okay.
This,
oh, yeah.
You see?
Yeah.
So it's not really fair to call that 470. It's more like 465.
Okay. So
but you see that curve, right?
Yeah.
So it follows the same power trend line, but the torque keeps going, and you can see there we exceeded 400 Newton meters of torque.
So that breaks.
What did we say the limit was at the dyno?
412.
412. So we were at like 417. So we're like right there. And if we kept going at lower RPM, this axle torque would keep going up. So we can't measure it anymore.
Right.
So this is the lowest speed that we can measure full power.
Okay.
And that was 470. Well, we said 465.
So why is the power and the torque tailing off from that peak?
Well, like I said, it would be good for the motor to be able to have 2 gears maybe. Because once it gets close to top speed, the motor does lose a little bit of power potential.
Okay.
And also there are thermal effects. So like we've basically got
so as the motor
starts reducing its power, it's available power that it'll allow.
Okay.
Because we don't have full control of the motor. If we did, we could probably say, I don't care how you feel, just send it.
Get it all,
But in this case, the motor always, as it's getting hotter and as the voltage is dropping, it's going to reduce the available power. So the start of that pull, the power limit was 310 kilowatts, and by the end it was 286.
Okay.
So chances are that we've got the Tesla drive unit taking a little bit of power away.
Yes.
And we've also got a little bit of more possibly...
efficiency loss,
and heat losses through the contactors and the fuses and all that stuff as it gets hotter.
I see, okay.
So that's the tough thing. It's easy to make big power in dyno.
Yeah.
The tough thing is to get on the racetrack and be able to do lap after lap and keep the power.
Right.
So this is stage 1 is just making it work. Stage 2 is trying to figure out these problems and find solutions.
For sure. Well, that's the fun of a project like this too.
Oh yeah, absolutely.
If you're someone like Sasha and think
but
that's
you can see here, if we look, you can see that, I mean, if we were able to, imagine if we could go back. Imagine if we could floor it a little bit earlier.
Yeah.
We would have been at 450 wheel horsepower from 7,000 RPM.
Yeah.
And by 11,000, we're still at 420.
Yeah.
And 7,000 to 11,000 is the equivalent of like, I can't think off the top of my head right now, but it's basically the equivalent of going from like, 80 or 90 kilometers an hour all the way up to like, double that almost, right?
Yeah.
So
it's a broad power.
So we're looking at RPM, and it's kind of confusing, but actually it's a pretty flat amount of power over a really broad speed.
It is, yeah. The speed at which it drops off is actually very gradual, isn't it? Yeah.
Right.
It's going to be a monster once you've got it fully sorted out.
Yeah, it's going to be ridiculous.
It is. Yeah, I'm stoked to see this thing drive. So,
because remember, this is the biggest thing about electric motors that you have to kind of conceive in your head. With a gasoline engine, you're normally flooring it.
Yeah.
But not at peak power. You're normally flooring it 3,000 or 4,000 RPM below peak power.
Exactly, because
if you've got a 440 horsepower engine, you're probably flooring it, but you're only at 300 or 250, and then you're waiting for the engine to rev, to get to peak power, then you go past it, then you shift. With this thing, it doesn't matter what speed you're at.
Yeah.
When you floor it, you have 440 horsepower.
Yeah.
Or so.
Amazing.
So it's just madness.
It is.
In that regard, that the power is just like, you get full power all the time whenever you want.
Yeah.
It's nutty.
Makes you realize how those Teslas are achieving the performance numbers they do from 0 to 60.
Yeah, the quarter mile stuff.
It's crazy how fast they are. And they're a big, heavy car.
That's
this is
like
only 3,200 pounds.
Yeah, this thing's going to be like, it's not going to be that fast in a quarter mile just because it's not going to have drag radials. It's not going to be set up for that.
Right.
But if you look at the guy in Ottawa, I think he was doing 10s or whatever. Like there's no problem to make. It's just crazy, just nutty.
It is.
Nutty power.
It is.
Even from a low speed, yeah.
I will admit, Pete, though, I miss the ITBs. You need to put ITBs
I know,
on
the
this
problem
thing.
is the sound. I know,
Yeah.
there's no doubt about it. The lack of sound is the biggest problem. If we could, maybe we can, take a Dremel to the final drive gear and screw up the gears a bit. So
Yeah,
it just
give us some
whines,
straight
like,
cut gear noise or
something,
something. Yeah.
Some kind of sound would be nice for sure.
We'll
There's
figure
no
that
doubt
out.
about that.
So next episode, maybe, what are we going to do? We're going to go for a
Driving.
drive?
We gotta be driving.
Going to go for a rip?
Yeah,
Just
we've
gonna
already
send it?
putted it around. So
Yeah.
that's definitely the next exciting thing to do. We just gotta send it, Dave.
Put a clamshell on the front and back. And
Roast the tires.
go do burnouts. Electric
Hopefully we
burnouts.
don't break anything.
That's kind of a environmentally bad thing to do with a green car, but we're going to do it anyway.
It'll be like a short burnout.
A short burnout.
Say something. Hello. I'm saying some things so that you can check audio, and those things would include me saying, I'm saying some things about you checking the audio level.